So the last intervention that we have listed there is pruning, because it's important, so we wanted to make sure that it was included up there. We're not actually going to go into detail in that one today, because it's something people are quite familiar with, how to realize value through pruning. So just summarizing then the 3 interventions that we did go into detail with, what is the value of this work to the industry? So with the characterization and segregation, so you're achieving gain within 0 to 10 years, and you can realize a gain up to 10% increase in return to log value. With mid-rotation nutrition, we've seen that in 10 to 20 years, you could be looking at a $5,000 per hectare increase in gross standing value at harvest. And finally, what we just saw with the optimal final crop stocking, that over that 20 to 30 years, we could be looking at $2,300 per hectare increase in net return at harvest, which, looking over this time period, is then a $1.7 billion gain. So that has essentially paid for the entire GCFF program multiple times over. Okay, so I think we do have time to take questions. Excellent. So we're starting with John. John, for the stand density management diagrams, why did you use mean diameter rather than, say, total base area or meters cubed per hectare? Do you think that would change your carrying capacity estimates?
Okay, thank you. So typically with stand density management diagrams, quadratic mean diameter, or essentially the diameter of tree with average basal area, is what's been used. People have used volumetric measures as well, so mean tree volume. The issue there is that when you introduce essentially a tree volume, you've got to get a height, a diameter, and use a volume equation, and essentially you would introduce an error by doing that. So diameter is the sort of standard measure that has been used, and so if we sort of just hone in on that, we have something that is really comparable across radiata pine, across other species in New Zealand, but also with what other people have done worldwide.
Thank you. Do we have another one? Question facilitators. There we go. Is any work being done on a publication that looks at investment returns for forestry that new investors can tap into? Any of our panel have comments on that?
So I guess there's a short answer that is, it's kind of a yes. We have actually been trying, and it's one of the things that's sitting with me, is to actually try and produce a publication that synthesises all the productivity interventions that we can make, and also actually looks at the impact that they have on productivity, but also the return that you might get, because obviously there's a cost of the intervention as well as the gain that you get from it. I have to confess it's still a work in progress, but I think it is something that it's important that we actually do develop, because clearly you make an investment in these interventions, you generally make them up front and you don't realise the return till the end. So having that greater confidence to invest is important. So I think that's something that we do need to sort of pull together, and it would be a nice legacy to have from this program.
Thank you. All right, we have 2 here that have sort of been moving in the top. Your average branch size graphs are interesting, but a lot of work was done on minimizing branch size impact using genetics and stock type. For branch sizes at end of rotation, was any difference noticed between seedlings and cuttings? Did small branch size genetics have much impact at end of rotation?
Me again. Okay, so one of the things that we we looked at in this trial was actually we had the breeding values for branch size in the trial, and we did some work looking at the impact of branch size differences among the genetic stock on value, and that actually was the trait that had quite an impact. I think from memory, it was about sort of 18% of the variation in value among the seed lots could be explained by their branch size rating. So obviously you had bigger branches. In many cases that was in the uninodal seed lots, so you probably had branch size coupled with probably associated poor stem form was depreciating value. In terms of differences between seedlings and cuttings, we didn't, I think in those trials we only had seedling material.
Okay, I know we have some more questions up there. I just want to give people who might not have a device a chance. Does anybody from the floor have a burning question they want to ask before we go back to the ones on the screen? Yes, we have a burning question over here.
We simulated with higher and lower NP discount rates, but we settled on 7, I think, correctly.
Yeah, I used 8% for the analysis.
Any other burning questions from the floor? All right, we can take a couple more from up here. Is the optimal stocking rate for carbon sequestration the same as for structural grade regime?
Yes, we haven't actually factored in the price of carbon into the analysis, but I can't imagine it will be lower. If anything, I'd imagine it will be higher because clearly you're still increasing the volume, but I guess you're going to reach a point where the trees are not going to make the min SED for the grade, and so there's going to be a balance there somewhere. But the easiest way to do that is just to add it directly into the model, and it will optimise the value based on the log rate and the carbon price. But it's a really good question.
There we go. There we go. How does adding in carbon costs affect stocking decisions?
I think it's the same answer.
Okay, same answer. There we go. Did you consider the environmental impact by increasing final crop stockings with regards to debris on site?
No, I didn't consider that.
But I think obviously that's something you do need to consider is, you know, with higher final crop stocking, you will end up with more taller, slenderer trees. So we need to think about risks from wind. We need to think about disease risk and also, you know, just the material left behind. If there's no or limited market for small diameter wood, you know, i.e. pulp market, just some of those other factors. But as Mike said, the short answer at the moment is no.
And nutrition.
Yeah.
That's right.
Yeah.
Okay, I think we have time for last question. And it looks like it's also for John. How have you gone against the original GCFF aim of doubling productivity without having a negative impact on wood quality?
As I say, thanks, Simon. No, it wasn't. Okay. I think what we've shown is that in many cases, if you're using full site occupancy to increase productivity, you certainly see from the impacts on outer wood properties that the two things generally go hand in hand. You know, I think many people in the room will sort of, you know the sort of history where we've particularly when we looked at 85055 material, you know, genetic material, and that had the strong negative correlation between growth and wood quality. There's natural concern that if we push productivity, we can have a negative impact on wood quality. But if you think about using site occupancy as a key tool to increase productivity, generally most of the impacts on wood quality at the moment are positive in terms of branch size, outer wood stiffness, outer wood density. The real thing that we need to look at is core wood. Do we end up with a greater proportion of wood contained in that first 10 rings when the trees are free to grow, and reduced proportion of wood produced outside that when there's greater competition among the trees? That's probably the thing that we really need to understand the impact of.
Excellent. Okay, I think we have reached lunchtime. So thank you to everybody for participating by asking questions. And let's thank our speakers again.